Section 5 in Chapter 8 is titled Constant Rate of Change and Direct Variation. By the end of this lesson, you'll be able to identify proportional and non-proportional relationships by finding a constant rate of change, and you'll also be able to solve problems that involve direct variation. So we have two vocabulary terms to begin. First is a linear relationship, and that's a relationship that has a straight line graph. So anytime you create a graph that has a straight line, it has a linear relationship. Also, we have constant rate of change. A constant rate of change is when the rates of change between any 2 points in a linear relationship are the same or constant, and we'll look at some examples today where that is the case. What I want to show you is constant rate of change versus rate of change. We discussed rate of change in section 4, and now we are narrowing that down and we're talking about discussing a constant rate of change. So the graph over on the right, which shows airplane position, vertical versus horizontal, we actually used this graph in one of our examples in section 8.4. You can see that this graph has a rate of change. You can see that the different line segments are increasing or decreasing or remaining the same. And so this is a rate of change. It's creating different line segments that get pieced together. But it's not a constant rate of change, because when you look at the graphs on the left-hand side, the first one shows a constant rate of change because it's a straight line from beginning to end. Similar with the graph on the right, we have a straight line that's decreasing from beginning to end. One thing that can help you understand if we're talking about a constant rate of change or not is that the difference between the x values in this table at the top, they're all positive 1. It's increasing by 1. And the difference in the y values, notice they're all increasing by 2. That also indicates a constant rate of change. So you can tell by looking at a graph if the rate of change is constant by if it's a straight line. You can tell by looking at a chart if the change in the x is constant and the change in the y's is constant. Over here on the right, again, we don't have a straight line of any kind. It's a up and down segmented line. So that is not a constant rate of change, but it still does have a rate of change because it's changing from point to point, A to B, B to C, C to D, D to E, and E to F. Now let's discuss proportional versus non-proportional relationships. So we have a proportional relationship, and you should be writing all of this down. We have a proportional relationship when the ratio of each y compared to each x is the same. So if you look at the table, we're talking about time and distance if something's traveling. We have distance on top, that's typically our y, and our time on the bottom as our x. We have 4 over 1 if you're looking at the first ordered pair on the graph or the first ordered pair in the table. 4 over 1 reduces to 4. If you look at the second ordered pair, and if you put the y's over the x's, we have 8 over 2. 8 over 2 reduces to 4. Finally, for the third ordered pair, we have 12 over 3 if you look at the y over the x. And 12 over 3 reduces to 4. So this is a proportional relationship because the ratio of each y compared to each x in the ordered pairs that create the graph reduce to 4. So then on the other side of that, a non-proportional relationship is going to be when the ratio of each y compared to each x is not the same. So now if we look at some of the ordered pairs on the graph, you see 1, 4, 2, 6, and 3, 12. In the table, they are denoted 1, 4, 2, 6, 3, 12. And if you compare the distance over the time, we get 4 over 1, 6 over 2, 8 over 3. And you can see that these do not reduce, or the ratios are not comparable because they're not the same. They are comparable, but they are not the same. So we have a non-proportional relationship because these are not the same. So we can look at a graph, we can look at a chart, and we can determine whether we're talking about proportional or non-proportional by writing the y over the x as a ratio and reducing that fraction. So let's look at an example. Here we have a graph that shows the cost of different amounts of trail mix. And we're trying to determine if there's a proportional linear relationship between the cost and the weight. So essentially you're asking yourself, as the cost or as the weight increases, does the cost increase at the same rate? So first we need to label these ordered pairs. You can see for the first ordered pair here we have 4, 14. Then we have 8, 28, and finally 12, 42. And now we want to take each of those ordered pairs and write them as a ratio, the y over the x, or the weight, or excuse me, the cost in money, which is the y, over the weight in pounds, which is our x. So for the first one, we have 14 over 4, and we want to see what that reduces to. Both of these numbers are divisible by 2, so we get 7 over 2. Next, we want to look at 28 over 8. And both of these numbers are divisible by 4. We divide the top and the bottom by 4. We get 7 over 2. So far we are looking at a proportional relationship, proportional linear relationship. But we do need to check all the points that we have here. 42 over 12. We reduce both of these numbers by 6. You'll see that you get 7 over 2. So we do have a proportional linear relationship between the cost and the weight. So essentially for every pound that you increase, then you will also increase by a cost. And we can reduce this further if we write 7 over 2 as 3.5. That means that for every for every 1 pound increase, we're going to increase the cost by $3.50. So because you could write this as 3.5 over 1, and remember it's cost on top. So for every $3.50 you spend, you're going to get an extra pound of trail mix. So yes, it is proportional. Direct variation is a real fancy way of saying slope, but direct variation is when the ratio of two variable quantities is constant. And we're going to talk about the direct variation and how to find what we call the constant of variation. So hopefully some of you remember the equation y equals mx plus b. It's a linear equation that you have seen before, probably not since 6th grade though, where m is our slope, x and y are our variables, and b is called the intercept. Well, in a case with direct variation, our b is going to be 0. You can see here that this graph goes through that y-axis or through the origin, so it does have a y-intercept of 0. So now we're just writing it as y equals mx. And here when we're talking about constant of variation, we use k to denote that, but you'll notice that it's just the same as our slope. Constant of variation then is when the ratio of two variable quantities, that should say is in there, is the same for any corresponding values. It's our k. So we're going to look at some examples, or an example where we have to find the constant of variation. So here in example 2 we have the time it takes to burn amounts of information on a CD varies directly with the amount of information. So you can see from the table we have the amount of information it's trying to burn onto a CD, 2.5 megabytes, 3.75, 10, and 25 megabytes, and then how long in seconds that takes. We're told that it varies directly, and we want to write an equation that relates the amount of information and or with time it takes. So the first thing you want to do is you want to find the value of k using the equation y equals kx. Once we find k, we can substitute it in and we'll have our equation. So we can choose any point in the table and then we're going to solve for k. So I'm just going to use this first point that's 2.5, 10. And I'm going to plug the 2.5 in for my x. I don't know what k is. I'm going to plug 2.5 in for x, and I'm going to plug 10 in for y. Now I have an equation with one variable, and I can divide both sides by 2.5. And that's going to give me a constant variation if I use a calculator, 10 divided by 2.5 of 4. So I know that my constant of variation is 4. Okay, to now write my equation. My equation is going to be y equals 4x. So I found the 4 by plugging in an x and a y ordered pair from the table. It doesn't matter which ordered pair you have because we were already told that it varied directly. So we knew that any ordered pair would have yielded the same k value or the same constant of variation. Finally, I want you to predict how long it's going to take to fill a 700 megabyte CD. So now we're told the x value. We know the constant of variation k, but we don't know here is y. So I'm going to write our equation y equals 4x. and we want to know 700 megabytes. That's going to be our x. So 4 times 700 is going to equal y, or 2800, and pay attention to what the y is in seconds. It's going to take 2800 seconds for you to fill a 700 megabyte CD. Now, if you want to understand a little more about how much that is in minutes, we can take 2800 and divide it by 60, and that'll give you 46.6 repeating minutes. So about 45 minutes, 3/4 of an hour, roughly, but 2800 seconds is how long it would take to fill the 700 megabyte CD. So we were able to identify proportional and non-proportional relationships using the rate of change, a constant rate of change. That was example 1. And we solved a problem using direct variation in example 2. In class, we will work on worksheet 8.5.